What do you have to do in CFD to actually stand out?
Things are so much different with all the digitalization of information. I don't think you can beat or you can find a shortcut across traditional training in CFD. You need to focus on what interests you and which field has or which sub-segment or discipline has better prospects. I was fortunate to have a very diverse mix of people that I got to learn from. It is true that engineering in general is still a male-dominated. CFD also has many different segments. I specialized in helicopter CFD. Somebody else might specialize in multi-phase methods or SPH methods. If you really want to make a career specifically in CFD, I think going for higher studies is probably the right thing to do. We cannot base a decision based on one interview or one user feedback.
Kanchan, thank you so much for doing this. Welcome to the show.
Hi, hello, Yusuf. It's an absolute honor for me to be here. Thank you for having me here. And how are you doing?
Good so far. Thank you so much for asking. It's going to be super exciting. I think we tried to shift the podcast 15 times or whatever, but now we've finally made it happen. Really, really cool. How did we actually get to know each other? When did you join SimScale?
I joined, I think, November of 2021, just when the pandemic was relaxing a bit. And you and I think actually worked together on one project. Was it a blog or a webinar? I don't recall.
I think webinar.
Webinar, yes. You helped me put together my first webinar, I think, that I did at SimScale.
Turbo machinery?
Yes, turbo machinery.
Yeah, yes. Okay, I remember. Yeah, perfect. Really cool. Yeah, for people who don't know maybe what SimScale is, we'll talk about that later on in the podcast. But yeah, can you give the audience a little bit of a background? Like, who's Kanchan in the first place? What are you actually doing at SimScale?
Yeah. So by training, I'm an aerospace engineer. I did my bachelor's in aerospace engineering from the Indian Institute of Technology, Kanpur. And from there, I went on to do my master's in computational fluid dynamics at Iowa State University. I graduated in 2011. And after that, I joined a company that specialized in developing software for helicopter aerodynamics, generally, external rotor aerodynamics. And that was where how I got started into, rotating machinery related simulations and a little bit exposure to other disciplines that come into developing these kind of products. And as I mentioned, like in 2021, I made my switch to product management at SimScale. And so that's what I do there. My responsibility is to drive growth and traction for SimScale, which is the world's first cloud native simulation platform. And I take care of the rotating machinery and flow control vertical at SimScale. So it's my responsibility to talk to customers, to understand what our users, how our users are using SimScale, what more features and capabilities they need to aid in their own product development, and translate that into software, simulation software.
Yeah, that makes sense. It feels almost redundant to introduce SimScale. If you're not living under the rock, I think everyone knows already what SimScale does and
that's good to know. Yes. Provide. Yeah.
Definitely. Really cool. How was your journey into kind of CFD? Like, what was intriguing for you? Like, why was it a fascinating topic for you? I mean, it could have also been like thermodynamics or maybe FEA. Why CFD for you, Kanchan?
So, fluid mechanics in general was something that always clicked for me, right? Like, so in India, we have this preparatory 2 years in high school where we prepare for our entrance examinations for engineering school, similar to SATs, I think, in the US. And so you have to study a lot of, high school physics, maths, and chemistry. Those are the focal points. And even back then, the chapter on fluid mechanics was just something that I would score like 100 on 100 every single time, because I just could understand it. But it was still equations, right? It was still Bernoulli's equation, Archimedes' principle. I was still to associate it with reality. Like, how do these equations translate into real world problems? And for me, that happened in so in my sophomore year, I took up a project because I was doing nothing in the summer and I could see a lot of my friends being very productive, right? Some people are learning CAD or they're doing some hands-on programming. So I just approached Professor T.K. Sen Gupta at IIT Kanpur. He is a very well-known figure in the Indian academic scene. He's retired now,
Hmm.
and he took me on. He said, just come to the lab from tomorrow
Hmm.
and hang around. And literally that's what I did for my first summer is hang around grad students, helping them with tech plot and helping them with just simply learning the run command for their codes without knowing exactly what I was running. So
Hmm.
that's where my hands-on exposure to CFD started, followed by an internship at Iowa State University. That's where I wrote my first code. And once you develop your own code, right, and you can see what kind of a problem you're trying to solve using these equations that you've been studying for so long, right from high school. Like it's math. A lot of it is math.
Hmm.
That's
Yeah.
that's when I got hooked, and that's when I decided that this makes sense for me. This is something that I understand. This is something I like and I'm good at. So
I see.
I decided to pursue more coursework. Even during my undergraduate, I used all my electives to pursue computational fluid dynamics related grad courses as well. And I applied for a master's to gain more experience in this field. And from there, it's
Yeah.
pretty much like I haven't looked back.
Yeah, really interesting. A huge chunk of the audience actually is from India. I'm
Mhm.
not sure. I don't have really much experience in how the educational system in India works, but do you think like the Indian people generally are more hands-on? Like they want to get their hands dirty?
Um, Actually, my feeling, things might have changed, right? Like I graduated from like with my BTech in 2009,
Hmm.
15 years now. But back then, that wasn't the case. So
Hmm.
the Indian engineering system, as far as I am aware of, and I've kept up a little bit about, how the curriculum has evolved, it is focused a lot on textbooks, right?
Hmm.
There's project work. There is also a lot of opportunities to get into research. But what I felt as a student, or actually I didn't realize this back then as a student, it was much later when I was doing my master's and working with the industry. I realized that as students in India, we don't think about real life problems. We're not asked to think about real life problems. We're still solving. We're still applying our engineering thinking and analytical skills to solve bookish problems. We're not doing
Hmm.
enough project work. There isn't enough incentive to take on internships. Be it in academia or in the industry, which I felt was not the case in the US. Even though I was a master's student, I had the opportunity to interact with the undergraduates there. They had a very nice, laboratories with all the commercial tools available if they wanted to get used to it. They had coursework in programming. They had coursework they had opportunities to actually take an entire semester off to do co-ops, which is basically internships. So those
Hmm.
kind of maybe it has changed a bit, but generally it was more textbook oriented, more write an exam or study to pass an exam kind of attitude.
Yeah, I see what you mean. How would you maybe not change the educational system, but how would you approach it? Like if you were a student again, be more hands-on, and how would you do that actually? Like putting it into practice, like your learnings from the books into
Mhm.
practice. How would you do it?
I would question more, right? Like
Hmm.
I would. So it's not like I did not have the opportunity to take on more project work. I could have applied for more internships and things like that. But I would question if, for example, if I am studying Navier-Stokes equations, right? Why am I studying that? Where does this get applied, right?
Hmm.
I mean, why am I solving or applying this to a lid-driven cavity problem? What are boundary conditions? Those are the kind of questions that I would ask my professor and try, or my teachers, like try and relate it to an actual physical problem. And I think if I were a student right now, things are so much different with all the digitalization of information, right? Not that we didn't have it back then; we had the internet and everything, but now it's so easy to network. It's so easy to get in touch with. established figures, maybe your seniors or others who have been there before you. And there's also such a great pool of study material online, right? So you're not just dependent on what you're learning in the classroom. There's Coursera, there's Udacity, there's Udemy, and kids are already aware of that. So I would definitely, leverage that, I think.
Yeah, I feel like a lot of people also who contact me on LinkedIn, they exactly do this, but then
Mhm.
they want to look for this competitive edge, especially in the industry. So how can you be the 1% of the top 1%? Like, what do you have to do in CFD to actually stand out? Maybe on your CV or whatever projects you might be working on, like how can you actually stand out? Maybe
It,
also
it
from your own experience.
it depends on, I believe, what kind of a role you're looking for, right? And I
Hmm.
understand that, as a fresh graduate or even as a final year student, you don't know yet, right?
Hmm.
So you don't actually know what should you focus on. Like, should you focus on more, developing your own code kind of project? Should you take maybe do that certification in ANSYS or something? So I think it's good to have a little bit mix of everything, right? So
Hmm.
especially if you're not yet clear, for some it's crystal clear. Like, for some people it's like, yeah, I want to go for higher studies. I want to go for a master's or a PhD in this field, and they know how to pursue that. But if you're not clear, then I would say focus on the fundamentals, right? Get your coursework in place. I don't think you can beat or you can kind of find a shortcut across the traditional training in CFD. You do need that. You do need
Hmm.
that traditional classroom training, but augment that with maybe some certifications or some coursework in that exposes you to uh, commercial software as it's used in for product development in the industry.
Hmm.
So that kind of
Which
gives
is
you
the
a mix of both, like an academic know-how, basics. It gives you a knowledge of the basics and fundamentals of CFD, and it also gives you a knowledge of, how exactly is this implemented in different industries or different kind of problems.
Yeah. Would you advise people to look for a mentor, maybe even in the industry? Because the thing I see also a lot of not only Indian students, but they reach out to me saying, like, I have three choices, maybe four choices to make for my studies, maybe master studies.
Hmm.
Not really sure. I might go for the one that pays the best. I'm not sure if
Yeah.
this is the right approach. What is your opinion to that?
Uh, a lot of speaking again from the experience of being an Indian student, especially if you're working hard to get into an institute like the Indian Institute of Technology, which is very sought after. It's prestigious, and it's. I think the mind frame that kids get into it is like, after this, my life is set, right? Like they get
Hmm.
into it from the perspective of getting a job. It's only later that different folks develop different interests, and they pursue maybe different career paths. But I think that's the wrong approach to see what would pay me more, rather than I mean, you need to focus on what interests you and which field has, or which uh, sub segment or discipline has better prospects. Yeah.
It's kind of a bit tricky, right? There is no single answer that would solve this
Yeah,
problem, because then if you choose path A, it might lead to a complete different end result than if you choose path B.
that is true.
Any other recommendations that you might have? Just general tips, maybe that especially beginners in CFD or maybe more intermediate learners of CFD can apply when it comes to career development.
One way definitely I'd say is networking, right? Like
Hmm.
talk to people, get on LinkedIn. There are lots of eminent personalities on LinkedIn, including, like, yourself. You are
Hmm.
creating all this resources. There are other folks like Rajat Walia, Kate Beck, that I am aware of. Or just get in
Hmm.
touch with your seniors from your alumni association, and start talking, start understanding what are the different career paths that people before you have taken. For example, like, I'm a product manager today, and right now I'm spending most of my spare time learning about product, like the entire field of product management, which has very little to do specifically with simulation or CFD. It's more fundamentals of product management as applied across industries, and I'm absolutely loving it. I did not even in my wildest dreams 10 years ago think that I would end up being a product manager. But
Mhm.
that's one career path. So the more people that you talk to, the more things that uh, the starting point becomes clear, right? And I feel that if you really want to make a career specifically in CFD, you want to, wherever that might take you 10 years down the line. But if you want to understand, or if you want to be an expert, so to say, in the field of numerical modeling, it could be, structural analysis, it could be, fluids, doesn't matter. I think going for higher studies is probably the right thing to do.
Mhm. What I really like about your story is like you were kind of a specialist, like kind of the CFD nerd, how I would call it, and then you kind of branched out. You became more of a generalist. Like, so how
Yeah,
important
yeah.
was mentorship for you and just learning from your colleagues at SimScale or just in general?
I mean, not just at SimScale also. I mean, definitely SimScale. I mean, we are a very diverse team with
Hmm.
people coming from very different backgrounds and who are experts in different fields of CFD, applications of CFD that you get to learn from. But even in my previous company, there were a lot of folks that I got to work with that who were coming from bigger organizations. Who had There was one person with me who had worked for NASA before, and I learned so much from him, right? Like he's worked on some hands-on space projects, and so I wouldn't say these are mentors as such. Definitely, I've
Yeah.
had mentor figures, my major professor being one of them, who's always, believed in me and always given me the opportunity to, do more. Uh, but I think more than such standout figures, which you may not be able to find, it's important to keep learning, it's important to have learning as a continuous process from everybody around you, everybody that you work with. And I was fortunate to have a very diverse mix of people that I got to learn from, especially who had, special. So they're all CFD folks, right? They have all had that kind of traditional CFD training, but they've gone ahead and applied that training to different fields, and that's where their enrichment comes from. And I get to learn about those through, vicariously, so to say.
Yeah, that makes sense. Really interesting. Do you think also the environment plays a huge role? Because of course, yeah, SimScale is a startup slash scale up. Still, some other startups don't work the way SimScale does. Because I felt when I was at SimScale, like as a junior, I was still
Yeah,
doing my bachelor's. You feel you could like kind of you have a lot of creativity. You could put that creativity into
yeah,
practice. So also the
yes,
environment
definitely.
allowed you to actually grow. Do you still feel like the startup environment is a better enabler of like expanding your skills, talking to different colleagues with different backgrounds, versus being employed as a CFD engineer slash product manager in a big corporation where the structures are kind of fixed and the hierarchy is kind of fixed?
Yes, definitely. I think because I think big organizations also tend to work, in siloed teams. So you are part
Mhm.
of a team, which is a big part of a bigger organization, and you have responsibilities that are limited within that team. So most organizations, and especially a starting level engineer and entry level engineer, might not have the opportunity to, go across teams, maybe upwards in terms of communication and learning, but not across to understand different disciplines. Whereas at a startup, the structure is flatter. There is some hierarchy, there is some level of uh, reporting that's there, but mostly and especially in an open culture like the one that SimScale has, where it's encouraged that you should go ahead and talk to people, even if it's somebody that you don't work with on a daily basis. If there's something that you need from them, or if it's something that you have an idea for a project, and you just want to discuss it with somebody in the company who happens to be an expert in that topic, yeah, you should just feel free to get in touch and start talking. So definitely, this the avenues to learn, interact, and grow are and the work is also, I think, I feel is you have to do more with less in a startup. So you are sort of pushed to be innovative. You're sort of pushed to be, to challenge yourself. Not saying that those working in bigger organizations are not challenging yourself, but sometimes it can become that, the role, if you yourself don't have that drive from within, then things may become a bit mundane. But that usually
Yeah,
doesn't happen in a startup.
yeah, absolutely. You talked about drive. One of the questions that interests me is like, do you feel in the space of CFD, which is mostly male dominated, did you always feel that you have to make up for being a woman, that you actually have to work or go the extra mile, work extra hard as a woman?
Actually, no.
Okay, that's
No,
interesting.
no. So I felt that generally in engineering in my first couple of years as an engineering student, right?
Hmm.
I was the only girl in a batch of 30
Hmm.
in my aerospace engineering batch. So initially, yes, there was this trepidation and there's this, you feel like you're an exotic animal or somebody
Hmm.
in this big place, and you're like what, 18, 19 years old, just fresh out of home and still trying to find your footing. But after those first initial couple of years, it is true that engineering in general is still a male dominated, like tech and engineering, they're male dominated. But I have
Hmm.
never been made to feel as if I'm any less, or if I have, or that I have to work extra hard. I mean, I have to work hard. Yeah, I have to be good at what I'm doing, but I don't have to uh, go over and above to prove myself because I'm a woman. I have never been I've never been in a situation like that with
Hmm.
my coworkers, with my superiors, my teachers, my mentors. I think I've always been treated equally. I've also been scolded by my teachers equally, like if I'm not doing well and you're reprimanded,
Hmm.
because I think it's the hard work and the talent that mattered.
Absolutely. It's interesting. I think it's going to be very inspirational for a lot of women who listen to the podcast, because I also get messages from female engineering students who will also like seek for inspiration. I think there was some good inspirational lines from you, Kanchan, in
I,
that aspect.
I guess I've also been lucky, right? Like because maybe I've had the good fortune of working in environments which encouraged equality. I mean, we know for sure SimScale is a place where we have about 35 plus nationalities. We have a good mix of
Hmm.
men and women, and there is a huge focus on diversity and inclusivity and equality. And in my previous company, also, though it was a much smaller organization, I think it was, as long as you could get your work done. And it's also a matter of, I guess, getting over that inhibition, right? Like what you hear from everybody, that oh, you're a girl in
Hmm.
this big sea of men. Are you going to be okay, right? Like just step out. Girls themselves also need to, I think, step out and place themselves in right positions, be confident to speak up, and that can take a little bit of practice. As I said, the first couple of years I was a little bit, not so confident to speak up in class, for example. But then once you get
Hmm.
used to that environment, I think it's all okay.
Yeah, very good advice. Do you think like how I always like to say it, like a surplus in effort kind of um, makes up for a lack of confidence? If you get what I mean? Like if you always put in enough effort and like you work very hard towards a goal, then you kind of get less and less, or you actually become more confident
Exactly.
at the end of
Yeah.
the day.
Yeah. Yeah.
Yeah.
I mean, if and you also have to push yourself, right? Like you have to push yourself to stand up and speak up for yourself,
Mhm.
right? If don't feel like you are a minority. And I feel in most educational institutions, in a lot of workplaces, I think, uh, and there's this very interesting book that I'm actually reading by Sheryl Sandberg, where she says that women actually have to demand a seat at the table. A lot of times
Mhm.
we don't, right? We
Yeah.
we hold ourselves back, thinking that we are a minority. Or, I mean, is it okay for me to speak up here? Is it okay for me to be part of the conversation here? I'm not saying
So this
that
is
there is that all workplaces and all educational institutions are always equal in how they treat
Mhm.
men and women. Uh, but there's like two sides to it.
But even if it would happen, if there would be not an equal treatment of men and women, still is, I think it's a kind of a mindset thing at the end of the day to actually
Yes.
feel empowered even as a woman
Feel
and just step
empowered.
out as you
Yes.
said.
Feel empowered.
Correct.
Like I feel empowered because I feel I have gone through the same training. I have gone through the same hard work and spent applied myself to get that same education that anybody else in the industry has, irrespective of who that anybody else is, man, woman, it doesn't matter. If I'm good at something and if I'm confident about something, I'm going to go for it.
Yeah, I like that. Some very inspirational words. I like
I
it.
hope
Really
so.
cool. Yeah, and we can pull that out as a separate clip for all the women out there who need some inspiration. I would like to ask you, how does a day of a product manager look like? Like, how does your day usually look like when you wake up? I don't know, 8 or 9 o'clock in the morning. Depends, I
Uh,
guess.
so I think a product manager is uh, the reason I love it is because it's just no 2 days are the same, right?
Hmm.
And it's not one project that you're working on. A lot of times, product management is also kind of used interchangeably or even confused with project management, but that's not exactly what we're doing. So we are kind of at the confluence of all the different departments in an organization, right? You are dealing with sales, you're dealing with marketing, you're dealing with engineering, you are talking to customers, and so you're also closely working with your customer success team. So which means that there are many different conversations, many different interactions a product manager has during a day, which basically no 2 days are the same, and you have to wear many different hats. So
Hmm.
as a product manager, I'm responsible for maintaining a roadmap. What are the features that I'm going to be working on, and how do I decide that? It's all data driven, right? So I need to be speaking to customers, and
Yeah.
that's the golden principle of product management, is that talk to the people, talk to your users, understand what they
Hmm.
want, and build a product that's actually useful to solving a problem rather than what your gut tells you is the good thing
Right.
to do.
Exactly. That would have actually been my next question. How do you conduct these interviews? Because I feel some of the startups that just go by gut feeling, they're not talking to their prospects or ICPs, and they just fall into this feature paralysis. Just more features will eventually solve the problem, where this is in fact not the case, right? So actually continuously talking to people. So how do you conduct interviews with engineers maybe or decision makers?
So it's a continuous process, right? Like talking to users, talking to not just the users of your own product, but generally subject matter experts in the industry in which your product exists is a continuous process. Yeah, you need to get out there, and in addition to talking to these people, I think it's also important to keep yourself as aware of the happenings in the industry as possible, so that you are up to date with what are the trends happening. And to some
Yeah.
extent, every product manager, I think, I know I do, at some point you're thinking about features, right? You want to ship something,
Hmm.
but how do you prioritize that? There's a huge backlog of things that needs to be done. It's your customer interactions and your user feedback that helps you to prioritize what should we do it, how
Hmm.
should we do it. And there's this also something that I read somewhere, that fall in love with the problem, not
Yeah.
not the solution. Don't go around building a solution or building a feature that you think will solve XYZ's problem. It might solve XYZ's problem, but it will not solve like 10 other users' problem. So you'd learn that only if you talk to as many customers as possible. And what I'm trying to do now is at least have two customer interactions every week, right?
Hmm.
More is better. If it's either
Yeah.
customer interactions or just reach out on LinkedIn to talk to subject matter experts, like, so we call it like expert interviews. So for example,
Hmm.
if I'm interested to learn more about AI, right? I mean, AI is the thing right now. SimScale also launched our very own AI module for preview of the simulations, and very soon it's going to be sitting. It's going to be uh, alongside the PDE solvers. But I'm not an AI expert. I, I I know how it works, but if I want to learn more, then I would love to talk to people who are experts in this particular field. I love to hear podcasts. But yes, as a rule, I think try and get on as many discovery calls as you can. And your sales team and the customer success teams are your buddies in this matter to get you on calls, because they're talking to a
Yeah.
lot of folks in the industry. They're talking to a lot of prospects and future customers. So even if it's you are not able to sell your product, you're still learning a lot about what problem is this person is trying to solve, and how either now or in future can I tailor my product to solve that.
Yeah. How do you overcome bias maybe in opinions? So maybe even if you interview experts, there might be a lot of bias involved, like for whatever reason.
Yeah,
How do
yeah.
you get rid of bias? Is it just more interviews?
How do you mean bias? Like
Bias
towards
in the sense of
particular
might be
tools
there
or?
might be yeah, they might be leaning towards maybe a feature or functionality or whatever pain they might have, because right now they have this like specific problem, but maybe it's not representative for other customers or problems or pains that exist out there. So does that go back to kind of how you prioritize the feature list that you have
Yes,
in the backlog?
yes, absolutely. So that's why I mean, we cannot base a decision based on one interview or one user
Yeah.
feedback.
Mm.
We have to talk to many users, many experts in that particular field to understand exactly, and that's where I said, right, like the problem might be the same, but it's better if you don't let the user tell you the solution. And, okay, I
Hmm.
need this feature. That's good. It's better to understand, you have a problem, and so also has probably also has that problem. And as a product manager, it's my job to figure out what the solution would be. And we always try to develop solutions that are easy to scale, so that are not focused or custom made for only one particular type of application, and they're
Hmm.
also easy to implement across the platform, as since scale has supports many different kinds of solvers. So that has always been the paradigm, and I'm also quickly learning about how to be good at uh, developing solutions that can scale, and that are
Absolutely, that
not
makes
very specific to one customer or one user.
that makes sense. I think it would be also interesting for another podcast episode to talk about the new AI functionality and PDE
Yeah,
solvers,
yes.
etc. So yeah, if people are interested, leave a comment down in the under the video, and we will make sure to cover that in one of the other podcast episodes. Anything we might have missed in terms of like career advice in general, or like people who want to become CFD professionals, maybe some professional advice from you, Kanchan.
Uh, well, what can I say? As I said before, right? Like if you want to be an expert in CFD, I don't think you can circumnavigate the traditional training in CFD. You have to go through it, right?
Hmm.
In your undergraduate, if you really want to get into the nitty gritties of it and deep dive into one particular, because CFD also has many different segments, right? Like I specialized in helicopter CFD. Somebody else might
Hmm.
specialize in multi-phase methods or SPH methods. Lots of stuff to do, right? So if you
Yeah.
want to go even step further, definitely go for higher studies. But in even within your undergraduate, uh, utilize your electives and utilize your all the coursework, course credits that you can get to actually learn the basics and fundamentals. It can be a bit daunting, especially like for, say, if you're a sophomore or a junior year student, and suddenly you're being asked to derive these huge equations that don't make sense. And that's where I would also recommend that try and complement it with actual real life experience. Take on projects, take on internships, speak to professionals in the industry. There are so many avenues available now which we didn't have, right? We didn't have
Hmm.
LinkedIn. The only possibility that we could get in, get some career advice was either go to these alumni association talks, or find people through our actual physical network and email them. But now you can actually literally just get on LinkedIn and follow people, follow blog posts. There's so many digital courses that are available that you can take. So
Yeah.
I would say that make use of those resources to keep on augmenting the traditional education that you're receiving in college, so that you're more prepared. You're more
Yeah.
aware of how where the industry is going.
Yeah, I think that makes a lot of sense. I think so. It seems like basic advice, like a no-brainer, what you said, Kanchan. But the thing is, it's so simple that people think it's like there must be some magic behind all of it, which kind of gives you the shortcut. But honestly, I think not taking the shortcut is probably the
No,
best
no, no,
shortcut.
no. Yeah, you
Yeah,
have you have to know the fundamentals, right?
yeah,
You have to do the coursework. You have to do the very traditional projects, and all the assignment kind of work where you're asked to develop so and so uh, equation and your basic textbook stuff. You have to go through that
yeah,
to get your
yeah,
fundamentals right.
yeah. What are some of your favorite CFD books, if you can remember any of those?
Uh, I I started with S.V. Patankar, Finite Volume Methods. So
Yeah,
that was
good.
like the go-to book for
Yeah.
our entire masters.
Hmm.
And I always like J.D. Anderson. I mean, it's
Oh yeah,
pretty,
that's good.
it, I mean, he writes in a very basic sense, but I think, again, he's very good at explaining concepts in a sense that that helps you relate it to the actual physicality of things, right? Like, what's the control volume, what are you doing
Hmm.
there, how does a fluid particle enter go. And other than that, like, a lot of my I like Prouty, which is helicopter aerodynamics, but then that's
Hmm.
very specific, I think. So for CFD, I would say JD Anderson is one of my favorite books.
Any other resources that you would recommend? Maybe not books, but just okay. I could say SimWiki now, but that would be biased.
Yeah, that'd be biased, right? Like, other resources. I don't know about certification courses because I think they can be expensive too, right? Like, it's
Yeah.
always not so easy to spend money. But
Hmm.
there are also like not so expensive options on Coursera, on Udemy. Udemy especially has lots of fundamentals of CFD, fundamentals of so and so software, fundamentals of programming, right? Like, I mean, you need programming to be a CFDer, even if you don't
Hmm.
intend to become like a CFD developer for down the line. So fundamentals of C++ or Python. So I would really recommend these courses on Udemy. You yourself, I think, have a few courses on Coursera. So
Yeah, correct.
those are very good to get started and get an exposure to the basic first principles,
Hmm.
and to kind of get your hands dirty with some kind of assignments and projects. And the good thing about all these courses, I think, is you can also link it to your resume from nowadays, right?
Yeah,
So you can actually show it on your resume when you're applying for jobs that, hey, I've done so and so course on so and a known platform.
yeah, definitely makes sense. But I also want to make people aware that too many certificates are probably also not the best way to go.
Right.
So I think practical applications, maybe even coding stuff and putting it on GitHub is maybe also
Also a good
um,
way. Yes. Yeah. Yeah.
definitely cool. Anything we might have forgotten, Kanchan, in the podcast?
You tell me.
Yeah, closing remarks from your side. The last word always goes to the guest. So
Okay. Well, I mean, I don't know if I made some. I hope I made some good points. And yeah, I'd just say that my journey was it, it wasn't something that I'd planned, right? Like,
mhm,
the only conscious decision that I took was that I want to be a CFDer. I like computational fluid dynamics. I'm good at it. Um, so this is what I want to pursue. And here I am as a product manager in
mhm,
the simulation industry. And now I am not just working with CFD, I'm working with a lot of other disciplines in the world of simulation. And I'm constantly having to upskill myself. Everybody has to, right? Whether you're a professional or an entry level student, or and you have to keep upskilling yourself. So that's part of the job. But so far, it's been a good journey, and I am really looking forward to learning more and more about upcoming technologies and see where this path of a product manager in the simulation industry takes me.
Really cool. Nice closing remarks. Also, I will put the link to your LinkedIn profile down in the description so people can also reach out to you if they have any questions. But yeah, very inspirational podcast, Kanchan. Thank you so much. And maybe there will be a second part in the future. Who knows?
Yeah. Thank you, Yusuf. Thank you for having me. I mean, it was for the brief time that we worked together, it was a real
Yeah.
pleasure to interact with you. And I've
Thank you.
been, following you, your work on LinkedIn and other platforms, and it's an absolute pleasure to be here, to have spent this past few minutes with you.
Thank you so much. Speak soon.
Yeah, all right.